let's take a look at some med math real quick and what that means as for a paramedic. You guys have gotten one of the worksheets to kind of work through so that you can kind of see how the calculations and stuff work. But just in case you still have questions about what does this really mean for me as a paramedic, let's throw some med math up here and I'll show you guys the vials so that it kind of maybe all comes together. The first thing we always have to remember is our patients are 2.2 pounds per kilogram. So most of our patients don't know how many kilograms they weigh, but they know about how many pounds they weigh. So let's say our patient tells us they weigh 165 pounds, right? And we need to convert that into pounds per kilogram. So in order to do that, we just need to divide the 165 pounds by 2.2 pounds per kilo, right? So that's going to cancel out on your pounds there. And that's going to, you'll have a calculator that you can use in your skills lab. So we have 165, divide that by 2.2, and that gives us 75 kilos. So that's how much our patient weighs. So if you have a weight-based dose and the doctor tells you to give 2 milligrams per kilogram, right, whatever drug it is, let's say 2 milligrams per kilogram. So how many milligrams does it take for this patient? So our dose is 2 milligrams per 1 kilo, and our patient weighs 75 kilos, and we need to know how many milligrams we're going to use. Now you could do this really simply by just multiplying, right, so here's our dose, 2 milligrams per kilogram. You can do it really simply by just multiplying 2 by 75, and that will give you your desired dose. But to show you kind of how the math really works out, I always like the is over of kind of algebra equations, because to me this is easy and it kind of makes sense. So the way that we solve for x is you just simply cross multiply, and then we're going to divide. So we're going to say x times 1 kilogram is going to be basically x, because the 1's going to cancel out. And then we need to find out, or we need to get these ones out. So 75 times 2, and I wish I was better at math in my head, but 75 times 2 is 150 milligrams, because that's what we're trying to solve. So I hope that kind of makes sense, but you can see how we just multiplied the 2 by the 75, or you can just do it real simply, because each kilogram that your patient weighs gets 2 milligrams of medication. So how much medication are we going to have to give? So this is our desired dose right here. So 150 is what we would give this patient to satisfy our doctor order for 2 milligrams per kilogram. So I hope that kind of makes sense. Now when it comes to drawing up our medications, let's take a look here. I'm going to show you the vial, and then we'll come back and plug it into our calculations so that you can see how much fluid or volume we're going to give our patients. So let's look at a vial of Lasix, or furosemide. So you can see up here in the corner, this is a 10 milliliter vial. So how much, so there's 10 milliliters in here. And then we're going to look at the center part here and look at our calculations, or our concentration. So the vial itself contains 100 milligrams of Lasix, and the concentration is 10 milligrams per milliliter. So we know that there's 10 milliliters in here, which equals 10 times 10 equals 100. So that's where those numbers come from. So we're going to look at this 10 milligrams per milliliter. So if we're giving Lasix to our patient, our normal dose of Lasix is going to be about 40 milligrams. So here's our concentration. 10 milligrams for every 1 ml. We need to give 40, but we're not sure how much fluid to draw up. So here's where we go back to our equation. Right, I got my milligrams here per ml, so the mLs are on the bottom. We need to give 40. So again, we're just going to cross multiply and then divide. So 10 times x equals 10x. 40 times 1 equals 40. To solve for x, you have to get x on one side by itself, and it's multiplied here. So to get the multiplication off, we're just going to divide both sides by 10. And then that's going to give us x, right? So those 10s cancel out. You can cancel your zeros. 4 over 1 equals 4 milliliters. So if I'm giving my patient a dose of 40 milligrams, and it's a concentration of 10 milligrams per ml, you could just multiply 10 by, well, you can multiply the 1 by, what, you know, you can do it in your head. This one's pretty easy, but this is how it ends up working out if you work out the equation. So we're going to give out our patient 4 milliliters of fluid to get 40 milligrams, which is our desired dose. So this vial here has 10 milliliters in it. I only need to give 4 of the 10. So I'm going to use a 5 cc syringe and only pull out or draw up 4 milliliters. That way it's a little bit more controlled and I don't accidentally overdose my patient. I know exactly I need to give 4 milliliters. I'm only going to draw 4. Now you could draw out all 10 because this is a single dose vial. So once we're done with this, we trash it. So you could draw out all 10 and then only push 4 milliliters from your 10 cc syringe or your 10 milliliter syringe. And then that would leave 6 milliliters left in your syringe. But if you accidentally kind of get it backwards or mixed up, you might overdose your patient. So I only draw out the amount of fluid that I'm going to actually give. It helps keep me from making med errors. So let's look at another one. So here is another vial of Lasix, so you can kind of see the difference. So here's our furosemide. This is a 4 milliliter vial, and so it contains 40 milligrams, and there's 10 milligrams per milliliter. So if our dose is 40, how much of this vial are we going to give? So you can work out your calculations, but what we know is there's 10 milligrams per milliliter, and there's 4 milliliters total, which makes 40 milligrams total. So we're going to use all 4 milliliters to get our 40 milligrams. So what if we only need to give, back in this frame, what if we give 20? So what if we need to give 20 milliliter or milligrams? How much of this vial, how much fluid are we going to pull out? Are we going to draw it? So it's easy for me to work things in like halves and quarters. So we know that 20 is half of 40. And this is a 4 milliliter vial. I only want to give half of the vial, so I'm going to give half of the 4. That makes it 2. But you can always plug your calculations in up there. Just change the 40 on the side to 20. Do your calculations and you'll end up with the same dose. So let's look at our preload of atropine. So both of these here are atropine. We have atropine in a preload. Normally you'll find the information on the box, so you can see atropine for injection. This is a 10 milliliter syringe, contains 1 milligram, so 0.1 milligrams per ml. And this one has the markings on it. And when you're giving these syringes, the top of the blue is going to be where your start line is. And so this comes in those purple boxes, and they normally come like this. There's caps. You just take the caps off, twist them together, and then now you have your atropine ready to go. And it's needleless, or you can pull the green hub, and then it's got a needle in it. So if we're giving 0.5 for our patient with bradycardia, right, how much atropine, or what's our volume that we're going to give? So we have 10 cc's, but here you can actually see the doses also. So if we're going to give 0.5, that's going to be right, let's get you back into focus here, which is 5 cc's, right? Because we got a 10 cc syringe, 1 milligram total, which makes 0.1 milligram per kilogram, or milligram per ml, excuse me. So if I only need to give 2, or I'm sorry, 0.2 of atropine, right, that's going to be 2 milliliters. I'm only going to push enough fluid for this blue to be right here. So that's our atropine auto-inject, or not auto-injectors, but preloads. So here's a multi-dose vial. This one has a concentration of 0.4 milligrams per kilogram, and it's got 20 in it. So generally we will use these multi-dose vials for organophosphates. So let's look at giving our patient 3 milligrams because they have an organophosphate poisoning. So let's go over here to the board and let's do the math on that. That way you can see, again, how this is going to work. So let's get rid of this. And let's get rid of this. Actually get rid of all of it, but in the interest of saving time. So I'm going to put the concentration of my vial over here. So 0.4 milligrams per 1 ml. We need to give our patient 3 milligrams. And I need to know how much fluid or how much volume to pull out of this jar to give to my patient in a syringe. So that's going to be our X because that's what we need to know, right? So there's our milliliters. So going back through, we're going to do the same thing. We're going to have to solve for X. So to do that, we're going to cross multiply. So we have, right, that one goes there. So we have 0.4 X equals 3. Oops, not 30. Equals 3. We have to keep X on the same side. So we're going to divide both sides by 0.4. And 3 divided by 0.4. So that's going to get rid of those. So we have X left. So X equals 7.5 milliliters. So if I have to give 7.5 milliliters, what size syringe do I need? Probably a 10 cc. And then I'm going to drop 7.5 cc's. cc's and ml are the same thing, so I tend to use them interchangeably, so hopefully it doesn't confuse you. But so we need a 10 cc syringe. We're going to drop 7.5 cc's or milliliters of atropine from this vial. And then that is our dose for our patient. Okay, so hopefully that makes sense to you guys. If you have questions, please feel free to email me, text me, or anything else that you guys need. Just let me know. I could always throw another video together. So I hope this helps. Thanks.